Okay, so for part 2 of area between curves, under, plane areas with polar coordinates. So we have area between curves. Okay, so let's say here we have um, two curves here. Okay, two polar curves, and we want to obtain the area between the two. Okay, so to solve the area in between them, so first we must get the area of uh, the larger sector. Okay, so and then subtract it with the area of the uh, smaller, okay, the smaller area. Okay, so the curve above is defined by RO, okay, the outside radius, and then this one, so this is described by inside radius, RI. Okay, so this area now, so this area is equal to the area of the area bounded by the outer curve, so that would be 1/2 integral of RO squared d theta, right? And then subtract it with the area bounded by the um, lower curve, okay, Ri, so which is 1/2 integral of Ri squared d theta, okay? So therefore, our area, we can simplify it as 1/2 integral of Ro squared minus Ri squared d theta. Okay, so we can use this formula, okay, to solve for the area between two curves. Okay, so let's say we have this example. So find the area outside the cardioid r is equal to 2 plus 2 sine theta, and inside the circle r is equal to 6 sine theta. So luckily, in this example, we are already given with the curves. Okay, so how the curves look like. So we have a cardioid. Okay, so from the name itself, so it's in the shape of a heart. Okay, and then inside the circle, r is equal to 6 sine theta. So obviously, this one is a circle. Okay, so we are asked to find the area between them. Okay, the area outside the cardioid, so this is the cardioid, and inside the circle, so this area is this one, so the shaded part. Okay, so that's the area that we are looking for. Okay, so obviously RO later will be 6 sine theta, okay, because it's above, and then RI, so the R below is 2 plus 2 sine theta. Okay, so all we need to determine are the limits. Okay, so for what values of theta are we going to integrate? So we must find the intersection of those two curves. Okay, so to solve that, so easy. So all we need to do is equate. So solve for the intersection. So r is equal to r. So we will have 6 sine theta is equal to 2 plus 2 sine theta. So transposing on the other side, so we will have 6 sine theta minus 2 sine theta is equal to 2. Okay, so we will have 4 sine theta. 4 sine theta is equal to 2, dividing both sides by 4. So we will have sine theta is equal to 2 over 4, so that is 1/2. So theta therefore is equal to arc sine of 1/2. Okay, so arc sine of 1/2 is, or r, so theta is equal to, so the first is at the first quadrant. Okay, that is 30 degrees. Okay, its sine is 1/2, positive 1/2. Okay, the other one is on the second quadrant. Okay, so which is also 30 degrees. Its sine is also 1/2. Okay, so therefore that is 30 degrees, and then if this is 30 degrees, then this is 150 degrees. Okay, so therefore we have two values for theta. It's at 30 degrees and 150 degrees. Okay, so if you check with your calculators, at 30 degrees and 150 degrees, both of their sines is 1/2. Okay, so 30 degrees, that is pi over 6, and 150 degrees, that is 5 pi over 6. Okay, so therefore this, our lower limit is pi over 6, and then our upper limit is 5 pi over 6. Okay, so therefore we will integrate between those two. Okay, so therefore our area now is equal to 1/2 integral of, again our formula, outside radius squared minus inside radius squared d theta. So we will have 1/2 integral of outside radius, that is 6 sine theta, and then squared, minus inside radius we have 2 plus 2 sine theta squared again d theta. So limits from pi over 6 to 5 pi over 6. Okay, so from here, your integral of trigonometric functions will be useful. So we'll have 1/2 integral of, so expanding this first, so we will have 36 sine squared theta minus, expanding this also, this will become 4 plus 2 times 2 times 2, that is 8 sine theta, and then plus 4 sine theta squared, 2 sine theta and then squared, so that is 4 sine squared theta. And then d theta from pi over 6 to 5 pi over 6. Simplifying, so we'll have 1/2 integral of 36 sine squared theta minus 4 sine squared theta, that is 32 sine squared theta minus 8 sine theta minus 4 from pi over 6 to 5 pi over 6. So unfortunately we can't apply Wallis formula here because as you can see our limits, it's not from 0 to pi over 2, so we have to do it the long way. So we can transform this sine squared theta, okay, but I think it will be useful to distribute the integral sign. So 1/2, so we can have 32 integral of sine squared theta d theta minus 8 integral of sine theta d theta minus 4 integral of d theta. Don't forget the limits, let's just write it outside, from pi over 6 to 5 pi over 6. Okay, so we can apply the identity for sine squared theta, that is what was the identity? Sine squared theta, so this is trigonometric transformation. Okay, so that is trigonometric transformation. So therefore, we can use sine squared theta is equal to, sine squared theta is equal to 1/2 times 1 minus cosine of 2 theta. Okay, d theta minus 8 integral of sine theta d theta minus 4 integral of d theta. So limit from pi over 6 to 5 pi over 6. Okay, so next, so we can distribute the integral sign and cosine theta here. So we have 32 times 1/2 times 1, so that is 16 integral of d theta minus also 16 integral of cosine 2 theta d theta minus 8 integral of sine theta d theta minus 4 integral of d theta from pi over 6 to 5 pi over 6. So I think we can add these two and then integrating, so we'll have 1/2. So adding this, we'll have 12 integral of d theta. Okay, and then integral of d theta is theta, so therefore we'll have 12 theta minus, so 8 cosine 2 theta. Okay, so integral of cosine 2 theta is sine 2 theta. Okay, but be careful with the constants. So we have 2 theta, so there should be 2 here, okay, 2d theta. So therefore, outside the integral sign, we must write 1/2. So therefore, this will become 8 sine of 2 theta. Okay, minus integral of sine is negative cosine. Okay, so this will become plus 8 cosine theta. Okay, limits from pi over 6 to 5 pi over 6. Okay, so substituting the limit, so we will have 1/2. So you have 12 times 5 pi over 6 minus 8 sine of 2 times 5 pi over 6 plus 8 cosine of 5 pi over 6. Okay, minus lower limit, so 12 times pi over 6 minus we have minus 8 sine of 2 times pi over 6 plus 8 cosine of pi over 6. Okay, so evaluating each, you have 1/2. So 12 times 5 pi over 6, so cancel, so this will become 10 pi minus 8 times sine of 2 times 5 pi over 3. So we have 5 pi over 3. Okay, so 2 times 5 pi, 2 times 5 pi over 6, so that is 5 pi over 3. 5 pi over 3, that is 300 degrees. So sine of 300 degrees, I think that is negative square root of 3 over 2 plus 8. So cosine of 5 pi over 6. So cosine of 5 pi over 6, that is square root of 3 over 2. Negative. And then minus, so we have here 2 pi minus 8 times sine of 2 times pi over 6, so that is pi over 3. Sine of pi over 3, that is 1/2 plus 8 cosine of pi over 6, that is 1/2. Okay, so simplifying, so I think this two will be cancelled. Plus positive, this will become 8 square root of 3 over 2, or 4 square root of 3. This is negative 4 square root of 3, so this will be cancelled. And this one will also be cancelled. So what will remain is 10 pi minus 2 pi. We have 8 pi times 1/2. So area is equal to 4 pi. So this is square units. Okay? So that's how you compute, okay, for the area between two curves.